Hello guys, good morning. Good morning. Welcome to another episode of Sao Talk Show. We are going to code Wolfram language today. So if you are here, say hi. Love to see your comments. If you are not here, play at 1.5 speed and skip around because I ramble all over. If you do not skip around, you'll just hear me rambling. Okay, so Wolfram language coding today. So let's begin. So yeah, my keyboards, Glove 80 Ultimate Hacking Keyboard, Nulia trackball, and then there is Svalbard, okay, Svalboard, Svalboard. I have a video review on YouTube on each one of them. Ultimate hacking keyboard in the middle. Okay, so I'm using Wolfram keyboard layout and I'm using Xafly keys. Okay, here's the source code. Xafly keys, the most efficient key binding system for Emacs. So you can watch a video introduction. Okay, more efficient than Vim. Okay, so let's start to code Wolfram language. The pink window shows all my command calls and keystrokes. For example, I move up, previous line, move down, next line, move forward by word, move backward by word, or go here, delete a tag, undo, you can see, and the keystroke on the left. Wolfram keyboard layout. Close. Okay, so open that, copy, close, paste a link, make a list, showing browser. Today's Sao Talk Show. So let's do Mathematica. So if you don't know already, watch my past videos. I have 100 videos on Wolfram language. Just search for Wolfram language. You can download it. Okay. So there's a lot of introduction I did in the past. Today we just gonna continue updating my visual dictionary of spatial plane curves. Okay. So last time we worked on parabola last week. So let's see what I need to do. Hello EU. Hi. Sprinkled nights. High tech bra. Jupiter. Are you married? Yes. How do you think about the Emacs release 31? Is that released yet? Let's see. So, hello, Based Science. Based Science has been following me on my Twitter, but I don't know who you are. You anon guys. Without knowing who you are, so it's hard to really actually know you guys. So Emacs blog, go to Emacs tutorial, go to tables of contents, go to practical Emacs tutorial, go to start at download. Okay, let's go to GNU. Let's see Emacs 30. Oh, Emacs 30 is released. Oh, I'm gonna install it today, later. Fantastic. Yeah, this is good, exciting news. Yeah, I'm gonna install it. So go back, copy the URL back to Emacs, and what is this? Close Emacs blog, talk show. Yes, paste link there. Fantastic, thank you. So Emacs 30, and then it's gonna be a few days of work, 1 week of work on digging in what's new, and then update my website, my Emacs tutorial, update my packages, things like that. So it's great. So now let's go back to Wolfram language. Let's see parabola. Okay. Let's see. I want to do. There is something. Okay. Go to the page, go to the top, search.mb, make a backup, Open it. Wolfram language notebook. Wolfram language, the most advanced programming language by a magnitude. I get donation from them. Okay. So last time we've been working on this. This is 30 years old. So my goal is to delete all these and update them and put the code on my website like this. So because time changed, this is 30 years ago. Today, usually you don't like download stuff and you just like go by web. Okay, so there is some, you see this, so many interesting properties. This one, for example, is not on my website. This is showing the tangent properties we did last week also, live. Okay, and there's that one, very interesting. You see this typeset in Wolfram language, one of the, just for this feature, you should get Wolfram language just for this feature, because you don't have to, you see, because, for example, okay, I'm digressing. For example, you paste that, paste again, Control Shift I, okay? So normally your source code looks like that in any normal programming language. Right? Your source code looks like that. But now you press a key, Control Shift N, it automatically became mathematically typeset, and they reformat on the fly. You see how the expression reformat on the fly, so you don't have to worry about indentation. This like programmer idiots, the C++, Java, Rust, these idiots for the past 30 years. This feature has been in Wolfram language since 1996, version 3. Okay, so let's go back. So that's a little digression. Let's go back. What I want to do, yeah. So that image, that's about the optical properties. I also need to update that. And this animation I did, there it is. We did it last week. Evolute of parabola. So this evolutes, let's see, search. Okay, let's just update this one. Okay, make a backup, close that, search for evolute. Okay, so there it is, that corresponds to this section. So so you can see this is image from 30 years ago. Go to the directory, 4 kilobytes, tiny. So let's update this one. Okay, so copy, cut, paste it here. We're gonna work on this one. Copy. So we're gonna put the code here, Wolfram language code, paste it, and pop it out so we can code in Emacs. This is, I'm using XA Wolfram mod. Search for the web, you'll find it. It's free on GitHub. XA Wolfram mod. Okay, XA Wolfram mod, there. So go to the source code. It's 3,000 lines of code. Go to the website, open it, show in browser, there. And it's on GitHub. Okay. So close that. So we want to work on this. Okay, so let me go to, I need to some packages, plain code plot, copy that. Okay, so evolute. Okay, parabola. So we gonna this is the formula we want. We don't want, so formula is that, and the new name is plane curve plot, not paraplot. Okay, actually I want to make, you see this paraplot. Okay, let me just show you a few things. Okay, parametric plot is a built-in function, so you can plot that by, let me show you. So remove that, remove that, remove that, remove that. Okay. So this is built-in. Okay, so let's draw that. Axis, okay, so you see that's the result. Now axis true, shift enter. You see that's what the curve looks like. But what we want to do is we want to draw the normals to the parabola. So what is a normal to a curve? So given a curve, any curve, pick any one point on the curve. You got the tangent. So tangent is the closest fitting line. Tangent, I should not need to explain because it's the simplest concept. So given a curve like that, so if this point P, there is a tangent, so the tangent would be undo. The tangent would be a line like that. So the tangent is a line that's closest to the given point. Okay, so if you want to say what is a tangent here, P, that would be a line like that. Okay, so a tangent here would be a line like that. Okay, so that's a tangent, the most fundamental idea in calculus. Now, what is a normal? The normal of a given point on a curve is a line that's perpendicular to the tangent. So this is a normal, okay, at that point. And over here, what? It's got confused. So over here it's like that. So over here it's like that. So tangent is the normal, is the line that is perpendicular to the tangent. Okay, so given a parabola like that, so close that, save. So you see here's a parabola, and all those lines are tangent. Now instead of drawing the tangent, you draw the normal, then you got these red lines, you see. So once you have a bunch of lines, you can see they form a new curve. You see this bunch of lines, they kind of form a new curve. And this new curve happens to be semi-cubic parabola. Okay, that's another curve. That's this one. Very interesting. So it looks like a V-shaped curve. Okay. And the formula is t third power and t second power. That's semi-cubic parabola. All these are historical curves. They have many properties that discovered by mathematicians. So anyway, let's go back. So normal, okay, so you draw all the normals. So our goal is just to programming graphics, computer graphics. We want to draw these lines. By default, you cannot do that because Wolfram language doesn't, so I wrote a package. Now, this package 30 years ago is called paraplot, but however, I renamed it to be called plane curve plot. So that's more sensible. People can understand, oh, plane curve plot. Before it was named paraplot, like kind of a shortening for enhanced parametric plot. But I think now it's better to have a alias so that it became backward compatible. Okay, so let's try to do that. So we go to the package directory, plane curve plot. So here's the source code, Wolfram language source code, 700 lines. Go to the directory. So here is the directory. Git, remove the backup, delete, yes, okay. Now open the package again. Now let's make an alias. Okay, so what we do is just plane curve plot and paraplot. So paraplot will just equals to, how do I type a equal there? So that's how you define an alias in Wolfram language. Basically, Wolfram language is a term rewriting system, symbolic term rewriting system. So this symbolic makes it different from the pattern matching in Haskell, in F#, in OCaml, or even in Lean proof system. I started to learn that. So this is how you basically, so this symbolic term rewriting system, which is different from like Lean or F#. So anyway, so once you declare, you create this alias, you also need to kind of go to the top and declare the symbol. Okay, so let me do that. Because this is within a package, so that means you have to be concerned about namespace. Okay, so let's go. Okay, begin right there. Okay, so clear plane curve plot, and let's see. Okay, copy that. Paraplot usage, same as plane curve plot. Okay, so that's inline documentation. I think it will work. I think that's it. So make a backup and save it, and copy to the Wolfram applications init directory. Okay, so that's done. I have a Emacs command to do that. So all I have to do is make some update, then press a key, it automatically copy that file to that directory. Okay, so now it's done. Okay, now close that. Now go back to our code here. So we can say we need to, so we were running this. Now we need to use the enhanced version, so this one. Okay, so let's delete that. Delete that. Okay, I think that's it. Remove that. Okay, that's what you need. Paste it. Please make it work. Shift enter. Oh, one-shot coding. No trial and error, because I know what I'm doing. Beautiful. Is that beautiful? What do you guys think? So now, copy it. Okay, fantastic. Delete that, and delete that. Okay, put the code back, and okay, and show in browser. Okay, then go down, go down, go down, go down, go down. You need to go to the evolute part. There is the code. Okay, now syntax correct, refresh, beautiful. You see, paraplot now works. Now you need to get the image, okay? This image we just did. So now go to the talk show, showing browser. Yeah, so go here, move the image here, showing browser. Fantastic. That's what we were explaining, the tangent and normals. Okay, this is so bad a drawing. Let's delete it. I don't want it. Delete, remove, showing refresh. Okay, now go back to parabola. Move the screenshot here. Close that. Refresh. Beautiful. Okay, so beautiful. So this old curve, this old one, open it, delete it, and remove the tags. And here's the annotation cut. Put the annotation here, parabola and its normals. Okay. Wait, so this is new, rename it. I can rename directly in HTML. Okay, so yeah, lowercase. Okay, now you see this alt annotation, we need to refresh it. So rename, relink, you'll refresh. So parabola and its normals. Okay, so let's see, go back here, refresh. Fantastic, we've done our job today. The evolute of a parabola is the semi-cubic parabola. Okay, evolute is the curve formed by these normal lines, the red lines. So you got this V-shaped thing. Okay, remove this redundant sentence. Just okay. I think maybe that's it for today. Make it short, one topic at a time. Any comments, I'll answer. So we talked about, we only talked about less than 30 minutes. So let's see, comments. The new completion preview mod is very cool. Okay, that's Emacs 30. I'll try that. That's gonna be a lot of interesting things. I'm gonna be busy. I'm gonna be so busy because I do a lot. I need to do a lot. It is the lean proof system. That's what I really want to know. Let's let me maybe talk about it. So this is my list of to-do. Like usually they pile up like hundreds and then thousands, like to-do, math, Emacs, Wolfram language, JavaScript, Python, Golang, CSS, Microsoft Windows, PowerShell, to read, to watch videos, review, like my articles, old articles. I have to now they are, I've been writing blogs for 30 years, so you have to review, especially tech blogs, and to do keyboard, Unicode, and research, so lots of to do. And one of the thing, so I've been starting to learn Lean programming language. I talked about it in the past few videos. So Lean programming language is a proof system. So it actually do mathematical proofs, which is a new field, kind of new era. Okay. In fact, this is the future of mathematics, because traditionally, you got mathematicians to do proofs manually. so by human. But now we got supercomputers. Why can't we use computers to help us? That is the goal. The ideal is, since computers can do calculation, why don't we just let the computer run and find all the new theories? Like, we don't need Einstein anymore. We don't need Einstein's relativity or whatever we got the supercomputers. The computer just churn out new theories that never seen before. And today also with the AI, AI bots, neural networks, artificial intelligence, machine learning. So, but it turns out it's it's a problem. You can't do that. First of all, so eventually over the past 100 years, we learned, oh yeah, let's just use the computer, prove everything. Oh, but we got problems. We got so many problems. The logic system doesn't work. If you use that logic system, you got that problem. If you fix that problem, then you got that problem. So you see, step by step, just like the history of AI, we learned a lot of things. And today, we still don't have any, like automatic proof systems at all. But we learned a lot. It's like all the past efforts is not waste, is good. We are learning things, just like machine learning and artificial intelligence. We learn, for example, in artificial intelligence, that writing poetry is actually not intelligent. Like today's AI bots, they can write poetries like 10,000 fairly okay poems in a second. So we learned that, like before, we were thinking, oh, writing poetry, that must be, you gotta be a human because it requires emotion. It requires the emotion to understand, the feelings of humanity. But not really. The machine can churn out 1,000, 10,000 poems. But do the AI bots, do they actually understand a thing? No. As if you have used AI bots, they are not intelligent at all. So anyway, let's go back to math. Okay, so proofs, logic foundation. We learned so many things. So you got set theory, then you got type theory. Type theory turns out is the way to go for computers. So we got, so that's a lot of progress. Okay. So I'm learning Lean. Okay, that's what I want to learn, because when you learn Lean programming, there are several of them. I have old articles. But anyway, there are several proof systems. They are so-called proof assistants. They are actually also programming languages. So Lean is one of the newer modern one, starting about 10 years ago. Okay, I decided I'm going to start to learn Lean. Okay, so let me talk about. So you go to my math blog, so you can search. So there is category theory. Okay, my notes is not good. So, but I want to. So one of the latest math foundation is this homotopy type theory, which is meant basically to replace set theory, which is the mainstream foundation for mathematics for the past few hundred years. Okay, set theory. But set theory, as we learned in the past 50, 100 years, set theory, it turns out, you can't use it on a computer. It's hard to work with. So you need homotopy type theory, okay, which is part type theory, part of the homotopy theory, which is advanced topology, very, very advanced, But it's like quite amazing that these two connects. Anyway, that's another history, okay? So So homotopy type theory, and that's not the only one. So right now, there are several approaches. We are the mathematicians, the computational mathematicians are trying to explore. So one of the popular, so anyway, I'm learning. So Lean programming language, okay? So it is good because you can read this book, Homotopy Type Theory. It's free. It's a PDF. I have some notes here. There's a PDF you can download, you can read it, okay? But reading only gets you so far. Reading is actually, that's a classic way to learn things. But now with the programming languages, it's much better if you actually hands-on learn the Lean programming language, because if your code doesn't work, then you understand nothing. Okay, when you read a book, type theory or category theory, you think you understand, but nobody can check you. But if you try to write a code, the computer will tell you you are an idiot. You think you know, you actually don't know, because your code needs to work. So I'm very excited, because this is different from reading this type theory textbooks, because you actually have to get your understanding provable by computer. Okay, that's a digression. That's it for today. Okay, so first time catching me doing Wolfram language. Okay, I'm not used to knowing about math in English, and I'm far from knowing this math. Okay, that's yeah. Well, this is basic calculus. This is kind of basic calculus. So you see, most programmers, they don't know nothing about math except in the past 10 years. Because in the past 10 years or 15 years, starting around 2010, you started to have this situation of big data. Like 10 years ago, it was a jargon, big data, 1 terabyte, petabyte, Google, they're talking about big data. And then machine learning. Oh, it's actually a new era. It's a new chapter in human history, okay? It's a new chapter in human history. So you got machine learning, you got big data, you got so-called on the rise the data science. Now I'm a data scientist. Then you got neural networks. Then you got, all of a sudden, 2 years ago, you got the Chat GPT. That's kind of like, that's a turning point in human history. Okay, Chat GPT. By the way, there are a lot of idiotic rumors, and like oh, we're gonna have AGI. Like whenever people talk about AGI or artificial general intelligence, or or the bots taking over, ignore it. Okay, they are totally idiots. Whenever you hear someone on Twitter, some of them are actually like professionals, like working at AI companies. But when they talk about how AI is gonna rule the world, or rob jobs, or the ethics of AI, like basically any of those topics, they don't know. They are just bullshitting you. Okay, they are grifting. It depends. Like some of them genuinely believe they have opinions, but this is just, that's my opinion. Okay, I'm telling you my opinion. So whenever you hear someone AI this or that, AGI, this all crap, like total crap. Okay, the question about what will the future of AI become? Will it become sentient? Will it become actually like general intelligence? Nobody knows. Okay, nobody knows. If someone claims I know, this is gonna happen next year. In 5 years, we're gonna, this Sam Altman, a criminal. He's an extreme bad person. Okay, this is my opinion. They are all scams. Okay, so we were talking about what. So what? Yeah. So that's. So the things. So yeah, I was going to say. So these things are basically calculus. Okay, kind of basic calculus. Okay. If you are calculus, if you are a math major, undergraduate calculus, so you need to know this. Okay, you see, like today you have hypes. People talk about cryptocurrency, bit money. They talk about blockchain, machine learning, neural networks, AI. To know all that, you need to know this. Okay, this is not drama, but but the least drama things you actually, in order to do all those things, especially rocket science like Elamus is doing, you need to know all of these. Okay, you see, so I was saying programmers in the past, they don't know math, because the typical programming Linux, kernel operating system programming, it's web dev. Most programming they got nothing to do with math. Okay, a little, like discrete mathematics. Okay, and then in game programming, also this little mathematics, except the game engine. When you're talking about computer graphics, 3D graphics, that's linear algebra and only linear algebra. You only need to know like 5% of linear algebra, like matrix multiplication, projection. So in general, programming is separate from mathematics. Okay, but not in the past 10 years. So because of the AI, so in the past 10 years, this big data, machine learning, that's heavy mathematics. Okay, the neural networks, that's a lot of these heavy mathematics, and also crypto analysis. You see, cryptocurrency. Okay, swap board. Okay, I don't know yet, so sorry about that. It's long delay. Ebonics for uncle. Why is that people like kept saying Ebonics? That like I have on my Twitter, someone asked me about, do you know Ebonics? Like that's just I don't like that term. Just like just say black English, just like black American English. What the fuck is Ebonics? And Ben, who are you driving now? You already know who is that. I can't type, but I'm listening. What's up, uncle? I don't know who you are. Okay. Okay, that's it for today. Thank you guys for watching. If you like my stuff, pay me. Okay, xarli.info. Go all the way to the bottom. Pay me Amazon gift card. Click the link. Use this. Copy paste this email address. Pay me $100 or PayPal. Okay, pay the real deal of free trade that will get you a prosperous society. Like free trade. You like my stuff, you pay me. Bye.